Previously, you read about exploratory analysis. In this module, we're going to look at packages that help with exploratory analysis. The packages that we look at in this module aren't included in your book, so you'll see throughout the notes or throughout the script here that I've included several different websites. And really, the packages that we see here are just scratching the surface of what is available. Many people that work in R that do repetitive tasks will often create packages to help with those tasks. So for example, in many publications there's a table 1, and in table 1 is where the descriptive statistics for any of the variables in the analysis are summarized, and this is a common table that needs to be built for publications. And so at the end of this script you'll see 3 different packages that work on building or help you build a table 1. So again, this is just scratching the surface, but it's good to be aware that these packages exist and then to always be on the lookout for them. And so the first two we're going to look at are VisDat and Nanyr. These are both going to help us with visualizing where missing data is occurring in our data set. And as part of an exploratory analysis, it's always good to know, one, do you have missing data, where that missing data is occurring, and then finally, are there any patterns associated with that missing data? And so missing values need to be carefully explored and handled in the initial stages of any analysis. And so again, we're going to look at a couple different packages that can help us. And so we're going to install both the Nanyr and the VisDat. So as a reminder, you probably haven't used these before. So if we try to run library and you get an error that says it can't find it, you'll need to do the install.packages first. And you can always go up to Tools, Install Packages, and then search for the package. And this is usually the way that I do it. It's just quick and easy. You also need the VisDat, and then also, of course, tidyverse. All right, so the data that we're going to look at comes from the VIM package, so I'm going to call it forward as well. And we're going to work with the diabetes data set, so I'm going to call it forward, and then let's read about the data set. So this data set consists of several medical predictor variables and one target variable, that's outcome. Predictor variables include the number of pregnancies a patient has had, their BMI, insulin level, age, and so on. And scrolling through here, we can see this is a data frame with 768 observations with 9 different variables. And so here are the different variables. And we could start out by just looking at some general summaries of this data set. We could always just use the summary data set, the summary function. And what the summary function is going to do is for each of those variables in the data set, it's going to give us the minimum, first quartile median, mean, third quartile max, and also notice it gives us the count of missing values. So if we look through here, we can see that outcome, for example, has no missing values. It has a total of 768, which is how many observations that we have. Age has no missing values, whereas insulin has 374 missing values. Blood pressure has 35, glucose has 5, pregnancies has 11. We could look at the structure of the data set, and so we see that it is a data frame, again, with 768 observations on 9 variables, and then we could see the structure of each of those variables included in the data set. Another one that we could use is the glimpse function. Now, glimpse is specifically part of dplyr. There are other glimpse functions that are available. So the way that this code is structured, here we have the package name, 2 colons, and then the function that we want to call. So whenever you have a function that you know maybe belongs to multiple packages and you want to call it directly from that specific package, you can always use this style code. And so similar here, the glimpse function gives us the rows, columns, and then for each of those variables, again, it gives us the type as well as a few of the first observations. All right, so we're going to use the VisDat package to help us visualize where the data is missing. And so VisDat provides a visualization of an entire data frame at once. And what it does is it provides information about the class of the data input into R, as well as whether or not the data is missing. So here, I shouldn't have got rid of that underscore, we're going to call viz underscore dat and then our diabetes data set. And we get this following plot. So what we have here is we have all of our variables along the top. Here along the left we have the number of observations. So we know that each of these variables has the same number of observations. That's 768. The color of the bar corresponds to the type, whether it's a factor, integer, numeric, or missing. So for example, if we look at outcome, remember that outcome did not have any missing values. And so you'll notice in the outcome bar there are no gray lines. In other words, there's no missingness. Looking at insulin, on the other hand, though, notice that insulin has a lot of gray lines. And so what that tells us is many of the values for insulin are missing. So this VizDat function is really nice because it gives you a really quick snapshot of your data set. We can quickly look here and we can see of all of the variables in the data set, insulin is the one that has the most missing values. And we can also see that some of the other ones have no missing values. So again, it's just a very quick snapshot of where the missingness or where the missing values in your data set are. There's also the function vismiss, which provides a summary of whether or not the data is missing. And it also provides the amount of missings in each of the columns. So let's look at vismiss. So vismiss doesn't have those nice colors that tell you about the type of the variable, but what it does do is, again, it marks the missing and the present. So those variables that are the light gray, again, no missing values. And those that are the darker gray or the black are missing. So again, quickly we can see that insulin is the variable with the highest number of missing values in it. So both of these functions are really good for just identifying are there missing values, where are those missing values, and how many missing values there are. What it doesn't help us do is explore relationships between missing values. Now I will say it does help in the sense of, if we come over here, if we look across, if we saw kind of a dark line that went straight across all of the variables, then we would know that that particular observation had many missing values, but it's still a little bit hard to see in this plot. So what we're going to look at next are some ways that we can explore the relationships of missingness, and are there any patterns with whether or not a variable has missing values. So let's start by looking at a scatter plot of insulin as a function of skin thickness. And here we're using ggplot. We've seen ggplot many times before, but just as a reminder, I'm calling the data set. My x value is going to be skin thickness, and my y value is going to be insulin. So as a reminder, when we say a variable name as a function of another variable, that is the same thing as saying that the y value is a function of the x value. All right, so let's run ggplot here. So here's what our scatter plot looks like. And if you were to count this, you would find that there are not 768 dots on here. And the reason for this is by default, ggplot only plots what are called the complete cases. So in other words, it's only going to plot observations that have both the skin thickness value and the insulin value. But we might want a way to visualize those observations that have either insulin missing, skin thickness missing, or both missing. And so one approach to visualizing the missing data is to replace NA values with values that are 10% lower than the minimum value in that variable. Right. So here we've got the ggplot diabetes. Again, we're going to do the same thing, except instead of geom point, we're going to use geom miss point. And here's what our new plot looks like. So what we have here is in the blue dots, we have the exact same points rather that we had in the previous plot. So notice all of these black points are the same as all of these like blue, teal points. What's changed are these ones that are in the red. And notice these correspond to the missing points. So if we look here, these points right here, they all had values for skin thickness. So for example, these 2 points right here had a little over 50 for skin thickness, but they're missing the insulin value. Remember, insulin was that one that had a lot of missingness. And so what happens is down here at the bottom, it has plotted their X value, but the Y value, since the lowest Y value was 0, it's placed these all lower than 0. And then the reason you see some of these stacked is because it doesn't want those points to lay right on top of one another, so that's what you're seeing the stacking. And then these points right here, these represent points where both skin thickness and insulin were missing. So we can quickly see that we have some points where both are missing. We have some points where only insulin was missing, but we had values for skin thickness. But we don't have any points where we knew insulin but not skin thickness. And so this implies that there is some kind of pattern there. And so this would be something we would want to explore more and figure out. We could also include facets to help us. So notice here I'm again going to use the geom miss point, but I'm also going to do a facet wrap based on outcome. And remember, for this data set, outcome told us whether or not the person ended up having diabetes. So again, running the code. All right. So here we have the no diabetes, here we have the yes diabetes. And now looking across these, the plots look very similar to one another. So what this tells me is if I'm interested in kind of a pattern that goes along with whether or not an observation is missing, it doesn't seem that the outcome tells me anything about that. And again, that's because the scatter plot for the no and the scatter plot for the yes look very similar. Whereas, let's say, for example, in the no category, I was missing, I had all of these red dots down here, but I had no red dots down here on the yes. That would indicate a pattern between the outcome and whether or not the variables were missing, or the values were missing, I should say. We could also use different themes. And so far, we've seen ggplot, and it pretty much has this standard look with the light gray grid pattern. It ends up there are lots of different themes that we can make these look different. Now this isn't necessarily going to help us with the missingness, but I put this in here just so you can see there are different ways to make ggplot look now that we've become more comfortable with it. And so notice the code up to this point is the same as what's above, but I've added in this theme dark. So here's just another way that you can make a ggplot look. And it ends up there's lots and lots of different themes. And you can follow that website to look at a gallery of different themes that you could look at. And so just as another example here I'm going to call the GG themes package. And again, you would first have to do the install.packages or come up here and do install packages. And notice this time again doing the same thing, except I'm going to call this theme. And so here's one where we don't even have the grid in the background. So again, these themes can make your ggplots look different depending on what it is that you're trying to do. All right, so let's look at some other ways that we can visualize missingness. In other words, are there any patterns with where our data are missing? So another one we could use is the gg missvar function. So again, I'm going to call this on the entire data set. And so what this one does is it creates kind of a line graph that moves from the left to the right, and it's really just giving me the count of how many observations are missing for each variable. So not as informative as some of the other ones, but again, it gives me this really quick snapshot to where again I can see that insulin has the highest number of missing values, skin thickness the second highest number, and then age, outcome, and this diabetes pedigree function all have no missing values. We could also, just like with the ggplots before, we could break this into facets by outcome. And so this is going to look at both the no and the yes outcome. And again, what I want to be looking for here is, does the pattern of where the missing values occur, does it look like it's different with the outcome no versus the outcome yes? And as I look across these, the values aren't necessarily the same, but the overall pattern looks very, very similar, which makes me think that whether or not a variable is going to have a missing value probably isn't related or doesn't have a pattern with the outcome variable. And then again, just to illustrate those different themes, here's what this would look like. Oh, and you'll notice I've been getting just a warning message here. It still runs without that. But my guess is the default for this function had guide equal false, and they would prefer to use guide equal none. I think that's actually probably an issue with how that package is written. So let me go up here just for good measure. Actually, we won't worry about that, but I believe if we were to, do what it's asking us to do, is it wants us to put guide equals none. And let's see if we get that same warning. No, and it's not happy with it. So we're not going to worry about that warning. I don't think it's actually affecting anything. All right, so then again, here's with this one. Notice the theme here. It didn't really make it look much different, and that can happen. All right, so the last package that we want to look at is the Table 1 package. And so again, this one is not included in your book, but I do have a website here where you can read this. So it's an R package that eases the construction of creating the Table 1. And so Table 1 is commonly found in biomedical research papers. If you work in epidemiology, you have definitely seen a Table 1. And so this package is just meant to help create those for publications. And it ends up there are many packages that help do this very thing. So I'm going to show you Table 1 here at the end. I've got some other ones, and I'll talk about those when I get to the end. So again, I'm going to call library table 1. You will want to have installed this package on your computer already before you run that. We're going to use the data set that we've seen before. It's that supraclavicular data set. So I'm just going to read that in, and then I'm going to view the data set for good measure. Make sure everything looks like it read in okay, and it does. I'm also going to use the diabetes data set from the VIM package. Again, calling it forward. We can read about it here. This is the one that we've just looked at, and then again to view it. So those steps, they were really just extra, but again, if you're coming in at the middle of the video and you're watching this next section, I just wanted to repeat it. So the very simplest use of the Table 1 package is using the create Table 1 function. And so we're going to look at this for both of these data sets. The first one is the diabetes data set. And what it does is for each of the variables in this data set, it is going to go through and give us the mean and the standard deviation. And so notice pregnancy means standard deviation, glucose means standard deviation, and so on. And then for the outcome, which is a categorical variable, it's going to give us the count for the number of yeses and the percentage of yeses. So notice again, very quick way to get the information that you would need for a Table 1. Now, I would not copy and paste this into a document because the text is going to look not so great. I'm going to show you some ways that you can make some pretty tables, but typically I would take this information, format my table in Word, and fill in the values. We can also do this for the other data set, and see we'll get something very similar. All right, now we may want to convert our categorical variables so they look different in the table. So let's look at how we could do that. So the first thing I'm going to do is just pull the names of the variables from that supraclavicular data set. And I'm going to do this using the names function and the dput function. So I'm going to run this. And this is a really handy function if you need to get the variable names from your data set into a way that you could copy and paste them quickly into a vector that you could use. So notice what this dput function did for us is down here in the console, it put all of our variable names in quotations, And then here at the very front, it has a C. And so remember that C, what that does is that combines these into a vector. And so I can just quickly copy and paste this, and now I have a vector with all of my variable names in it that I can work with. So what I would do is I could copy and paste that here into the script. Oops, that's the wrong. There we go. Now, what I really want from this is I want to make a vector of the variables that I want to summarize in a table. Now, if I look through these, I don't really want to summarize subject. Subject, all that is in my data set, if I go back to it, is that's just an ID number. I don't need to know the average or the standard deviation of ID number. So what I want to do is just remove that one, but then all of the other ones are ones that I would like to summarize. And you'll notice that's what I have here. So I'm going to delete that. And I've named that my vars. Now I'm going to create a second vector that's going to contain the variables that are categorical. So for this particular data set, the only categorical variables are group and gender. Next, what I'm going to do is create a table 1 object. So I'm going to use create table 1 again, but this time I'm going to specify the vars, and vars stands for variables, and so I'm going to give it that vector of variables that I just created, and that's the vector that has all of the variables in it. I'm going to set my data equal to the data frame, and then factor vars, those are the categorical variables. And so I'm going to set that equal to that vector of categorical variables that I just made a minute ago. So let's run this, and then I need to run these two first. There we go. I'm going to create the table, and then let's call the table. And so now notice that group and gender, they are correctly specified, whereas up here, group and gender were given a mean and a standard deviation, and we got that mean and standard deviation of subject, which we didn't really need. So this goes back to the importance of whenever you're doing an exploratory data analysis or you're summarizing variables, the first step before you ever do anything in R is going to be to actually know what your variables are. Are they categorical or are they quantitative? Because if they're categorical, you're going to want to look at percentages. If they're quantitative, you're going to want to look at probably means or standard deviations, and we'll look at some other options here in a minute. And then you may just have ID variables that you don't need summaries of at all. And so one thing that's important is if we look at both group and gender, so going back to this data set, notice that group is coded as 1 and 2, and gender is coded as 0 and 1. So even though these are coded as numbers, they really represent categories. And so that's why we don't want to look at the mean and the standard deviation. We want to look at the percentage that fall into each group. So if we go back to the corrected table, notice if we look for group, we can see that 49.5% fall into group 2 and 44.7% are gender 1. Now, of course, that's not that meaningful, the 2 and the 1, but we're getting closer. It's looking better. Now, if we wanted to, what we could do is we could go through and use mutate and change those 1s and 2s and 0s to 1s based on the data dictionary into something that was actually informative. All right, so we've created that table 2. Now we can also print table 2. So let's see what this looks like. So here we have printed table 2, and the nice thing about using the print instead of calling table 2 directly is notice up here in the categorical variables, when I just call table 2 directly, for those categorical variables, it just told me the percentage that were group 2 and the percentage that were gender 1. When I use the print and I add in the show all levels equals true, I get the percentage for all categories under group and all categories under gender. We could also do the summary function for table 2. And this is what the summary function will look like. Now, the summary function for table 2, it's actually going to give us even more information than just the generic table 2 when we call it. So again, we can go through here and see, like for BMI, for example, there were 103 observations, 3 of them were missing. So of course that means 3%, because 3 of 103 is about 3%. We get the mean, standard deviation, median, get our quartiles, min, max, and then a quantitative measure of skew. Now, a quantitative measure of skew, and then over here we have what's called kurtosis, is far beyond a course like this. Typically, when we think of skewed variables, and we're going to work with those here in just a minute, we're really looking at a plot and seeing whether or not it is skewed. The other way, if we didn't want to look at a plot, and again, we don't want to get into using these skewed and kurtosis variables, is we could just make a comparison of the mean and the median. If the mean and the median are relatively close to one another, then we probably don't have a skew in the variable. So if we look down through here, notice if we look at fentanyl, for example, the mean is 21.32 and the median is 0. Well, since the mean is larger than the median by quite a bit, this tells me that if I were to make a plot of this, it's probably going to be skewed. I could always just do a quick check as well. So for example, maybe I just want to do a quick histogram and I want to look at my data set. So I'm not going to worry about labeling my axes or anything like that. I just want to get a quick look. Does this variable look like it has a skewed distribution? And it definitely does. We can see that it has a right skew. Now typically when variables are skewed, we don't like to use the mean and the standard deviation to describe them. We might instead want to use the median and the IQR. So we can also identify or label which of those variables are skewed. So in this case, I'm going to create a vector called skewed, and in it I'm going to put the name fentanyl, because fentanyl is the variable that's skewed here. Now when I go to print table 2, notice I'm going to set non-normal equal to that skewed vector. And if I run this, I need to run that first line first. Notice now, if I look at the fentanyl variable, we use median and IQR to define that. So typically, if we have a variable that we think is skewed, again, median and IQR tend to be better descriptions of those instead of mean and standard deviation, which are often used when we have data that is not skewed, or a variable that is not skewed. We can also summarize by group, and so here I'm going to create a table 3. So again, I'm using the create table 1 function. I'm setting vars equal to that full list of variables. I'm going to set strata equal to group. And remember that group was one of my variables in the data set. Data is going to be equal to the full data set. And then factor vars is equal to the vector that had the categorical variables. And then again, I'm going to print it, and in the print function, I have set non-normal to be equal to that vector that includes the variables. That should be summarized using median and IQR. And now I get a new table, and we can see that it has been stratified by group. And so we have group 1 and group 2, and we have the summaries for each of those. And then we also have a little bit of extra information that follows after it that you can look at as well. All right, but we're primarily focused, again, just on descriptive statistics at this point. Mean, median, mean, standard deviation. We're not getting into inferential procedures in this course, and so that's why I'm not going to cover the p-values here. And again, this is just one potential package that will help you build that table 1. Some other ones are the table number 1 package, and then there's also the GT summary package, which includes a function called table summary. Highly recommend exploring these, especially if you think you're going to be working with R in the future and you know you're going to be having to build table 1s for publications. Each of these works slightly different, has slightly different functionality, so I think which one people use is really just a matter of a preference. I personally don't have a preference between the 3 of them. I've talked to people that have used all 3 of them for different reasons. So again, I do encourage you, to at least click on those websites, kind of explore those a little bit and see what you can find out. So as always, I want to end the video by saying, if at any point you have any questions, you need any help, please let me know. Post to that virtual discussion board. Just let me know what you need. And as remember, you can't break anything in R, so exploring and, playing with the code is really the best way to learn it.